Today's topic of discussion is chopper. A chopper is an electronic circuit where thyristor is used to switch on supply to load for certain interval of time and switch off the supply another certain interval. This cycle of operation, that is on and off, is repeated. To turn on thyristor, a gate signal is applied, and to turn off thyristor, some method of force commutation is needed. Now figure below shows the basic circuit diagram of chopper. Here thyristor T1 is triggered by applying gate pulses. It is acts as a switch here. When thyristor T1 is on, the output voltage is equal to the input voltage, that is V, and during the off time of this thyristor, output voltage is equal to 0. This figure shows the output waveform of chopper. During the on time of chopper, output voltage is equal to V. That means during the on time of the chopper, output voltage is equal to V, and during the off time, the output voltage is 0. The area of this rectangle is T on into V. If we form a rectangle whose base is T and whose area is equal to this area, then suppose this is the V average. The area of this rectangle is V average into T, and this area of this rectangle is V into T on. If we equate this, then we get this height is called the average value of the output. Here we written this V into T on, this is the area of this rectangle, and the area of this rectangle is V average into T. Then V average is equal to V into T on by T. T on by T is called, it is denoted by alpha, and it is the duty cycle. What is duty cycle? Duty cycle is the ratio of the interval during output remains high to the total time period. And duty cycle T1 by T, and where 1 by T is equal to alpha, this 1 by T is called the chopping frequency. So if I express the average value in terms of duty cycle, then it is VA average equal to duty cycle into input voltage, or T on into F into V. T on is the on time of the chopper, F is the chopping frequency, and V. If T on is constant, T on and V is constant, then average value is proportional to chopping frequency. The value of T on or chopping frequency, so varying the value of T on or chopping frequency, average value of output voltage can be varied. What are the application of chopper? Chopper are used to obtain variable DC voltage from constant DC voltage. Because varying the average value, we can vary the output voltage. This principle is adopted to obtain a variable DC voltages from constant DC voltages. There are two methods to control the duty cycle alpha. These are constant frequency system and variable frequency system. Now in constant frequency system, the frequency That is, the time period is kept constant and on time is varied. In constant frequency system, the chopping frequency is kept constant, but the on time of the chopper is varied to vary the output voltage. As T dashed on in this figure, T dashed on is the output on time of the second waveform, and T on is the uh, on time of the first waveform. Obviously, T dashed on is greater than T on. T is constant, so average value of the second waveform will be the larger than the first one. So it is called time ratio control or pulse width modulation. Now the variable frequency system. In variable frequency system, on time T on of the chopper is kept constant, T on is kept constant, but the chopping frequency is varied. Chopping frequency is varied means the time period is varied. In this figure, frequency of the second waveform is low. Chopper is kept constant, but chopping frequency is varied. As a result, the average value of the output is varied, as V average equal to F into T1 into V. Here T1 and V is constant, so average value is proportional to frequency, chopping frequency. So by increasing the chopping frequency, you can increase the average value of the output. Okay, thank you.